Hello and welcome to part 94. In this video, we will continue our discussion on asynchronous programming and we will learn more about async, await and task keywords. In the last couple of videos, we have seen async and await keywords. Async and await keywords are fundamental to asynchronous programming in C#. They work together to simplify the process of writing non-blocking code, making it easier to read and maintain. We can write non-blocking code using threads also, but using async and await makes our code more readable and it makes our code more maintainable. As you can see in this picture, in the last video we have created this method fetch data async. Here we have called this API using HTTP client dot get string async function, and we have used the await keyword here because this is a network call that is happening here, right? So this will take some time to complete, so we don't want to hold up the main thread, so that's why we have created this method as async, and at this line we have used the await keyword, and once we have received the result from this URL, then we are returning that result, right? So this is how we were using async and await keyword. In this video, we will take a deep dive and understand other features of async and await keywords. Okay, first let's go with async keyword. The async keyword is used to mark a method as asynchronous, right? If a method is marked as async, then it would be called asynchronously, right? It indicates that method can perform a non-blocking operation and return a task or a task result object, right? Either we can return a task or we can return a generic type, meaning we can return a task and within that we can specify the type which you want to return. If you remember, in this method we have used string here because here we wanted to return a string that we have received from this particular URL, right? And here are some of the features of async keyword. It can be applied to methods, lambda expressions and anonymous methods, okay? And it cannot be applied to properties or constructors. And async method should contain at least one await expression to make it asynchronous. In the past videos we have seen, if you don't use await keyword, then the method will be called synchronously. So to make the method call asynchronous, we have to use at least one await expression in our method. An async method can have multiple await expression, allowing for multiple non-blocking expression. So within one async operation, you can maybe use two API calls, or you can call one API call and one database call. The point I'm trying to make here, we can use multiple await keywords in one async method. And async method can also be chained together, right? We can chain two async method together, allowing for a complex asynchronous workflow. Meaning what you want to do, like you want to hit an API, and once you got the result from that API, you want to push that result to a database. So there are two asynchronous methods that you will be creating and you want to chain them together. So that can be easily done using the async methods. Now let's learn something about await keyword. Await keyword is used within the async method to temporarily suspend its execution. Okay, so await keyword can only be used within the async method. It cannot be used in any normal method. If you try to use await keyword in a normal method, you will receive a compilation error. So it temporarily suspends the execution, okay, until the awaited task is completed. If you remember, here we have used the await keyword, so we were waiting here to complete this HTTP call, and once that HTTP call was completed, then only we were going to the next line and returning the result. This allows other tasks to continue executing in the meantime, ensuring that the application remains responsive. It can only be used in an async method that we have already discussed, and it can be applied to any expression that returns a task or a task result type. Okay, so it can be applied to any method that is returning a task or a generic task response object. Okay, it unwraps the result of task result object, allowing you to work with the result directly. Let's understand this on Visual Studio. So I have opened up my Visual Studio and I have an async method that returns a list of strings. Okay, so this is the list of string that we are returning. Let's call the get list method. And if you see here, if I try to store the result of get result, okay, if you notice here, what is the return type? What we are getting here after calling the get list, we are returning a task of list string. Okay, so it is not the list of string directly. We are receiving a task of type list string. Okay, but once I apply a wait keyword here, you will notice I will get the compilation error because my method is not async. So let me put async here, and now if you notice the result type of this here, it becomes list of string. So what await is doing, it is basically unwrapping the result which we were getting from the get list of method. Let's go back to slides. Next point is it automatically handles the exceptions thrown by the awaited task, allowing you to catch and handle them in the calling async method. Await keyword can be used when you are working with using keyword, when you are working with for each loops, when you are working with log statements, and that is possible after C# 8.0 version. Let's now understand the task keyword. Task is a class that represents a asynchronous operation that can be awaited using the await keyword, right? It provides several methods to create and manipulate such tasks, such as Task.Run, Task.FromResult, and Task.WhenAll. The task is a generic class, so we can pass the type like this. So this can be any object. Okay. So this is a class. A subclass of task represents a asynchronous operation that returns a value of type TResult. So let's go back to the Visual Studio and understand the task class. Okay, let me remove this piece of code. So let's create an async method. Let's use public static async, and this will return a task. Let me call it get list. Okay. And what it will do, let's say it will make some API call that will take some 5 seconds to complete. So let's simulate that behavior here, and let's put await task.delay, and let's put the delay of 5 seconds. Okay. And what we want to do, we want to return a list of string from here. So let's create a list of string that we want to return, and return the list of fruits here. You will notice we are getting the error here. That is because when we are trying to return this, it is not a task, right? Because the return type of this is a task, but actually we are returning a list from here, list of string from here. Okay, to make sure this method is able to return a list of string, we need to change this task from task to list of string task. So basically what we are saying, I am using the task class, but we are specifying the type as list of string. Okay, once you have added this, now the compilation error is gone. So now let's try to invoke this get list, where result equal to get list. And if you notice here, what is the return type of the get list? It is a task, right? It is a task object that we are getting here. And what we can do on task object, we can put a await keyword like this. But for that, our method should also be async. So let's make it async here. So we can put a await keyword like this. Okay. And then you will see the return type is changed to list of string. But let's for now remove this await keyword and let's keep it as a task only. So with task, we have a continue with method that we can use to do some operation after we have received the result. Let me show you how. So when I will say result dot continue with, you can notice here continue with will take an action that can be performed after we have received the result. So let's add some code here and do some operation which we have received. If we see here, we are returning the list of fruits in the lowercase. So what I want to do as part of this example, I want to make this list to uppercase after receiving it. Okay. So let's do one thing. After we have completed this task, so the result will come as X. Okay. So I will create a lambda expression here. Okay, and the result will be coming here. If you see the return type here, it is still task. So what we need to do to get the data, I'll create a list of string here, and let me call it data equal to x dot result. Okay, so if you see here, x is in type of task object, but when we say x dot result, it will return the result which is returned by this task. Okay, so basically we will have our list of fruits in data variable. Once you have the data, you can do a for each loop on the data list and just print the item in uppercase. Let's put console.writeLine main thread completed, and at the end let's put console.readLine so that we will have at least one thread alive, because we don't want program to get terminated before we complete this task here, because this task will take 5 seconds to complete. Okay, so let's run the program now. You can notice our main thread is getting completed, so we are not blocking our main thread. It is a non-blocking call, and you can see after 5 seconds the fruits are returned, and that is in uppercase. So what we have done here, we have received the task from get list method, and we have appended continue with method, and we have basically defined this is the task I want to do once I have received my data from the task. Okay, so after 5 seconds it will return the data here, and once the data is received, it will loop through the list using the for each loop, and it will change all the item to uppercase. Okay, so this is how you can use continue with method from the task class. Within the task class, we have two other important methods that are available, that are WhenAny and WhenAll. Let's try to understand these two methods also using one example. So let me get rid of this piece of code, and let's create three methods, three async methods. Okay, so this is my first task that takes 1 second to complete, and after that delay is completed, I am printing task1 completed. So let's create two more tasks and copy paste this piece of code. Let me change it to 2, 3. Let's change it to 2. Let's change it to 3. Let's say task 3 takes only 500 milliseconds to complete, and task 2 take 5 seconds to complete. Okay, now we have the three tasks. Let's create one more async method to run all these three tasks. Let me call it run task, and let's run this task like this. Okay, so these are the three tasks, and in our main method let's call the run task method so that we can start these three tasks. Let me say run task. Okay, so if I run my method as it is, let's see what will happen. Main thread completing, task 3 getting complete, and task 2 is also getting complete. Let's say we want to complete some work once we have completed all these three tasks. Let's see how we can achieve it. So here we have the three tasks. So you want to wait for all these three tasks to complete. For that, we can use WhenAll method from the task class. So there is one static method that is available in task class, that is WhenAll. Okay, and you pass all these three tasks to it. And if you see here, what is the return type of WhenAll? It is a task. So you can put a await keyword here to make sure all these three tasks are getting completed here. And what you can do, you can put the console.readline and say, okay, let's run the program now and see the behavior. You can see task 3 getting complete, task 1 is getting completed, and now task 2 is also completed, and then we are saying all tasks are now completed. So using WhenAll method, we can add multiple tasks to it and wait for them to complete. And there is one more method, that is WhenAny. As the name suggests, it will be waiting till here till at least one of the tasks is getting complete. Okay, if you notice here, T3 is the smallest task because it completes in 500 millisecond. Okay, so let's do one thing, run the program and change the text here. So because we are saying WhenAny, so it will wait here till at least one task is completed. So let's run the program. Again, you can notice here main thread is getting completed, so we are not blocking our main thread. And you can see task 3 got completed, and immediately after task 3 was completed, we printed one task is now completed. And at the back end, task 1 is task 2 was still running, and whenever they completed their work, they also printed their console.readline messages. So this is how you can use WhenAll and WhenAny methods from the task class. And that's it for this video, guys. In the next video, we will continue our discussion on task class and see some of the other useful methods from the task class.